In Step 1 of Measure, you determine the specific sub-process that is now the subject of your Greenbelt project. In Step 2, you'll create a standard for the performance of that process. This is the point when you determine the best way to turn what the customer wants into a numeric measurement. This measurement will later be compared to the measurement of your current process in order to see how well you're meeting the customer's need. Click Next to continue. In Step 2, you'll become familiar with the components of a good performance standard, including the operational definition, specification limit, target performance, and defect definition. You'll also learn about the two types of measurements that you can make, discrete or continuous, and recognize examples of each. Once you understand all those concepts, you'll be able to write a performance standard for our commercial loan sales case. Click Next to get started. Why write a performance standard? We already know that reducing the data entry time will support meeting the customer's CTQ of on-time delivery of funds, so why don't we just get started? This is where the numbers become important. For one thing, what does reduce mean? If we reduced it by 20 seconds, would that be good enough? Or do we need to reduce it by 20 minutes? The performance standard translates the customer need into a clearly defined, measurable characteristic. Click on Next to learn how it's done. A good performance standard includes an operational definition of the process, a target performance, specification limits, and a defect definition. Click on each term to view its definition, then click Next, and I'll show you an example. Let's start with the operational definition. Its purpose is to remove ambiguity so that everyone, including the customer and all GE staff involved, has the same understanding of the process being investigated and agree on how to measure it. First, let's tackle the question, what is the process, by looking at an example from the airline industry. Airlines know one of their primary customer CTQs is on-time flights. Here is a sample of how a customer defines on time. Here is how the airline defines it. Can you see a problem? The customers are concerned with getting in the air, but the airline is only focused on getting them onto the plane. The result is that the airline is advertising 99% on-time departures, yet the customers still are unsatisfied because they're sitting on the runway for 2 hours before the plane takes off. Now you see how important it is to get customer agreement to the definition of a process. In this example, we'll adopt the customer's definition of on-time departure. So click Next, you know what it is, and we'll look at the next step is determining how do I measure it. Let's begin by talking about data types. You need to be aware of two types of data, discrete and continuous. You can access glossary definitions of these terms by clicking on the hyperlinks or click Next to hear my descriptions. Discrete values can only vary by a finite amount, which cannot be further subdivided. For example, counting the number of people that walk into a room in an hour is collecting discrete data because 1 is the only unit of measure for a person. A half person couldn't walk in, right? Looks like Siggy has another way of explaining this concept. Click on In Other Words to hear from him. Then click Next to continue. Continuous data, on the other hand, can be refined to any degree of exactness. Time is a common example of continuous data. We often put convenient constraints on time, measuring it in years, months, days, hours, etc. But in reality, you can refine those measurements to infinity. Think of the Olympics where runners win by 1/1000th of a second. Now that's detailed. And if you had the right tool to capture the measurement, you could refine that number even further. How far we refine a measurement depends on the needs of a given process. Oh, there's Siggy again. Click In Other Words to hear his explanation. Then click Next to continue. The CTQ does not dictate the data type. It is up to you to determine the type of measurement you collect. Here's a table showing some CTQ types and examples of discrete and continuous data for each. You should always aim for collecting continuous data because with it, you can more accurately assess your process. Before you continue, click on Tell Me More in order to read an additional explanation of the data types. When you're done, click Next to practice making the data type choice. What about our airline example? The goal is to assess the on-time performance of an airline and use the information to seek possible improvement. Which of the following approaches would be better suited for that task? Select the appropriate measurement and then click Done. I think you're catching on. Calculating the difference in time is a more detailed measurement of on-time departure data due to the nature of continuous data. If you choose A, an example of discrete data, you would only know if the flights left on time or if they didn't. That limits the information you have to work with in improving the performance. You'll learn more about how this data will help you when you get to the analyze phase. Answers the questions, what is it and how do I measure it? To determine the other three components of a performance standard, you need to first ask the question, how much variation in performance will the customer tolerate? Is a 15-minute late departure too late to satisfy their need? The answer to this question will set your specification limits. The answer can come from a variety of sources, but should always reflect the voice of the customer. In this case, let's say that a customer survey determined that customers would tolerate a flight leaving the ground up to 10 minutes late. Your upper specification limit then becomes the scheduled time plus 10 minutes. In many cases, you will have a lower specification limit that mirrors the upper limit. But in this case, a flight leaving before the scheduled time would not make customers happy because they could miss it. So the lower specification would default to the scheduled departure time. The target performance is where we will aim our process. In a perfect world, there would be no variation in the performance of a process or creation of a product. In other words, it would be done exactly the same way every time. So in that perfect world, we could say our target performance for the airline is departure at the scheduled time, and we would get that each time. But in the real world, there is variation in performance. Sometimes you're a few minutes early, sometimes a few minutes late. The goal of Six Sigma is to reduce that variation in performance so that you are as close to the target performance as possible, thus providing a high degree of customer satisfaction. You'll learn more about the statistical concept of variation in the Analyze section of this course. The last component of the performance standard is a defect definition. A defect is any nonconformance or any item outside the specification limit. Another way is to think of a defect as anything that results in customer dissatisfaction. In this case, a defect would be any departure time before the scheduled time or more than 10 minutes late. In Analyze, you'll hear about defects per million opportunities, or DPMO. Each creation of a product or performance of a task is an opportunity. In this case, each flight that takes off is an opportunity for on-time departure. Phew, I know that was a lot to cover, but I wanted to make sure you understood what a performance standard is all about before we work on Siggy's commercial loan sales case. Click on Tell Me More to see some examples of defects and opportunities related to a variety of CTQs. When you're done with that chart, close it and click Next to continue. Based on what we know, what question do we need to answer first to begin writing the performance standard for the Commercial Loan Sales Office? Select the appropriate question and then click Done. Correct. To write the performance standard, you first need to define the exact process. The answer to this question needs to be worked out with the customer. In this case, that would mean the internal customer. But first, click Next to determine how we should measure the process. Coming back to the commercial loan case, we know that the high-level goal is on-time delivery of funds to the customers, so our project goal is to reduce loan application time. For the performance standard, we need to turn that goal into a numeric measurement. Right. As mentioned earlier, continuous data provides more detail about the process, so we should be measuring actual time. A time of 45 hours could be caused by a very different factor than a time of 80 hours. If discrete data such as yes or no is used, we might never identify and eliminate the causes at the root of the defects. Siggy has reviewed existing GE procedures on this process and talked with the sales manager and some of the data entry associates and loan applications processors about the loan application process. Here is the official GE operational definition, which these internal customers have also agreed to. The loan application data entry process is the actual time from receipt of the loan application by the data entry associate until all of the required data is entered and ready to be submitted to the credit bureau. The customers have also provided some other useful information. Click on the pictures of the sales manager and the application processor to see what they had to say. So here's what we know from the customer. Let's wrap up this performance standard. First, I want you to try it yourself. Use the information we've gathered to select the specification limits, target performance, and defect opportunities per year from the drop-down lists. These are your answers. Let's talk about each component and you can see how you did. The upper specification limit is 72 hours because after 72 hours, the time is having an impact on the company's ability to deliver funds on time. The lower specification in this case is 24 hours because the company requires that amount of time to allow for manager review of all applications. That makes a defect any time under 24 hours and over 72. You also heard that under stable conditions, with no time-consuming errors in the forms, a good processor can complete this task in 48 hours, so we'll make that our target performance. Finally, the sales manager mentioned that the office processes 110 applications a month. Each application represents one opportunity. Take that times 12 months in a year, and you get 1,320 opportunities per year. Click Next, and let's pull this all into final form. In Step 2, you became familiar with the components of a good performance standard, including the operational definition, specification limit, target performance, and defect definition. You learned to recognize the two types of measurements that you can make, discrete or continuous, and to aim for continuous data as a measure of performance. Once you understood those concepts, we were able to write a performance standard for our commercial loan sales case. Click Next to summarize the standards we established for GE commercial loans. So what we've learned about the loan application process in Step 2 of Measure is this. Our operational definition of the application data entry process time is the actual time from receipt of the loan application by the data entry associate until all of the required data is entered and ready to be submitted to the credit bureau. And our standard for performance of this process is a time of between 24 and 72 hours, with a defect being any time under 24 or over 72 hours, an opportunity being each application that arrives for processing, and with a target performance of 48 hours. Click Next to continue. We're at the end of Step 2, and now we know our project focus and have set a standard for its performance.